Good morning, students. Today we'll discuss about atomic radius. Atomic radius. What is atomic radius? I already explained in the previous class. But today we'll discuss about the atomic radius. Trends in group and period already finished. Just in group we are verified how it will change. So if you take first A group elements. First A group elements means lithium, sodium, potassium, rubidium, cesium. So francium is radioactive element. That's why we are not considered. So in a group from top to bottom, atomic radius gradually increases. We know that one because number of new shells added increases. That is the reason. We know that one. So, in case of first A group elements, lithium, sodium, potassium, rubidium, cesium. So, cesium, what happened here? Atomic radius gradually increases. So, how it is increases, we will explain with the help of graph. So, we are taking atomic number on one axis and atomic radius in another axis. Other axis we are taken in picometers. So atomic radius is measured in picometers, nanometers, and also picometers, nanometers, and angstroms. So here we are taking the measurement is picometer. Here 50, 100, 150 picometers, 200, 250 picometers. This is atomic radius. This is atomic radius in one axis. This is atomic radius. So here 200, here 150, here 100, here 50. This is atomic radius. Atomic radius in picometers. So here, lithium, when observe the lithium, 152 picometers, sodium 186 picometers, potassium 230, 244, 262. This graph intimate from lithium to sodium, potassium, rubidium, cesium gradually increases. Atomic radius gradually increases. Therefore, it is explained about the atomic radius in a group gradually increases. So 152, 186, 231, 244 and 262. That means which one having highest atomic radius? Cesium having highest atomic radius. It is in alkali metals. This is in observation in the alkali metals. Alkali metals means first A group elements. First A group elements. So same thing will repeat in other group or not. This is correct. If it is repeated in the same group or it is also repeated in the other groups. So one more group we will observe. The group is 7th A group. Halogens. So this is halogens group. Halogens. So here halogens means they are also called as 7th A group elements. They are called as 7th A group elements. 7th A group elements are fluorine, chlorine, bromine, iodine, astatine. So actually astatine is a radioactive element. We are not considered the properties of the radioactive elements because they disintegrate alpha beta particles. So that is we are not considered the properties of radioactive elements. So here also francium in here francium. Francium is radioactive element. Therefore, we are not considered that properties and we are not compared that element properties with the other elements in a group. So therefore, here fluorine 72, chlorine 99, bromine 114, iodine 133. What happened here? From fluorine to iodine, atomic radius gradually increases. This graph intimates that from fluorine to iodine, fluorine, chlorine, bromine, iodine. So fluorine is this much, chlorine is this much, bromine is this much, iodine is this much. So what happened here? Atomic radius gradually increases. So by these two graphs, we are confirmed that in a group, atomic radius gradually increases. So that is intimated in the alkali metals and also in the seventh group elements. So this is the trend of atomic radius in a group and period. So in alkali metals, atomic radius gradually increases. Same thing will repeat in the halogens also. So this is about trend of atomic radius in a group and in a period. So here one more thing, in a group increases, in a period decreases. That is, so we are already given that example. So after that variation of atomic radius in transition elements. So how it will trend in transition elements? How it will trend in transition elements? Once we will observe that one. Once we will observe how it will trend. So here variation of atomic radius in transition elements. Variation of atomic radius in transition elements. How it will trend? So actually it is decrease. In transition elements it is decrease. But when compared to the representative elements, the trend increasing is that much is not observed in the transition elements. Means in representative elements that will more, but in case of transition elements decrease, but little bit decrease. So that only difference between transition element atomic radius and representative elements atomic radius. So once you observe the third transition, the 3D transitions, first transition elements. What are first transition elements? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Iron, cobalt, nickel, copper, zinc. So here scandium, from scandium to titanium, vanadium decreases. So once you observe decrease. So here this is the size of scandium, this is the size of titanium, this is the size of vanadium. From chromium up to vanadium, from chromium to decrease. Chromium to copper, there is no change. Almost similar. So almost change means almost similar. So almost similar. So here chromium to copper almost similar. After that zinc atomic radius is more than copper. So this is the trend. So scandium to vanadium, scandium to chromium decreases. From chromium to copper, the atomic radius is similar. From here to here, decrease. After here, similar or same. Similar. from zinc here increase. This is the clear trend. So this is the clear trend. So why it is decrease? So here in d block elements, core electrons are there. Core electrons. What are core electrons? Shielding effect of core electrons. So first is why it is decrease. What is the reason? Shielding effect of shielding effect of core electrons. Shielding effect of core electrons, and also additional shielding effect of second point. Additional shielding effect of d electrons. These are the two reasons. What is shielding effect? What are core electrons? We know that. So here core electrons means the electrons present in between nucleus and outermost orbit. So this is nucleus. For example, this is nucleus. So these electrons are called outermost electrons. These electrons are called core electrons. So the electrons present in between nucleus and outermost orbit acts as screen and reduce the attraction of the nucleus over the outermost electrons. So therefore reduce. So that's why this is one of the reason. So shielding effect means, that is the definition. So by shielding effect of core electrons means these inner orbit electrons are called core electrons. These are called outermost electrons. So shielding effect of core electrons and additional shielding effect of d electrons. The electrons present in between nucleus and outermost orbit acts as screen and reduce the attraction of the nucleus over outermost electrons. And this is the reason. These are two reasons. Why copper having less atomic radius than zinc means zinc has paid electrons. Due to paid electrons, repulsions takes place. Electron repulsions takes place, size increases. So why zinc has more atomic radius than copper means due to paired electrons, repulsions, it has atomic radius more. This is about trend in transition elements. So here, after that, so scandium. Next we will discuss about the trends in the lanthanides and actinides. They are called as F block elements. These are transition elements. Remaining are called inner transition elements. How it is called? So in the case of inner transition element, one property we consider, that is called as lanthanide contraction. What is lanthanide contraction? We'll discuss. But in case of represented elements in a group, gradually increase, in a period gradually decrease. But in case of transition elements, decrease. Some different trend is there. Scandium to chromium decrease, chromium to copper similar. So, but copper having less atomic radius than zinc because of two reasons: shielding effect of core electrons, additional shielding effect of d electrons. What is shielding effect? We'll discuss in the IP. We have explained clearly shielding effect, effective shielding effect. What is? We'll explain clearly. But just the word is mentioned here. That is shielding effect. So, due to paired repulsions, zinc having more atomic radius than the copper.